There's one other kind of friction that I want to talk about, and that is called kinetic friction, and it is what results when you have two objects that actually do slide and move relative to each other, like so. Like I said, this is called kinetic friction, and the reason for these names is that static friction refers to the fact that there is no relative motion, and kinetic refers to the fact that there is relative motion between the objects. Like with static friction, we can build a quantitative model for kinetic friction. Just like static friction, we're going to symbolize the friction force with Kf. Again, maybe on book 1 by book 2, you can put whatever objects you have of interest there. And unlike the static friction force, where we can only say that the force is less than or equal to some magnitude, for kinetic friction, you can actually say that the magnitude is equal to mu k, or mu kf, times the corresponding normal force. And once again, this is an equation about magnitudes, so I'll put my magnitude signs on there. Similar to the direction for static friction, the kinetic friction direction is always opposite the actual relative motion between the objects. So here, it's a little bit easier, actual relative motion. So once again, I can try this out with an example, right? Here are my two books, right? They are sliding relative to one another, which means when the top book is sliding that way, the relative motion is in that direction, which means the kinetic friction force on the upper book by the lower book is going to point backwards, opposite the direction of the actual motion, and it will have a magnitude which is given by exactly this equation. One last fact to know about the coefficients of static and kinetic friction is that, in general, the coefficient of static friction is greater than the coefficient of kinetic friction for any medium that you have. And this coefficient, both the mu s and the mu k, are properties of the substance that is interacting. So these are properties of whatever you have interacting with each other. So here I have been using two books, which might have a decently high coefficient of friction, but you can imagine all sorts of other examples of objects that might interact with each other. For example, here I have a piece of paper which could interact with the book. That might have a very different coefficient of either static or kinetic friction than the two books do. And you can imagine more extreme examples, like covering the surface of the book with water or oil, which might really drastically lower both of the coefficients of friction. Pretty much regardless of what your system is, you are always going to have that the static coefficient friction is greater than the coefficient of kinetic friction.